Welcome to my YouTube channel. In today's lesson, I will be covering more concept lesson number 3. And in today's lesson, I will be covering the following subtopic, stoichiometry. And in the subsequent lesson, I will cover the following topics, concentration or molarity, and also limiting and excess reagent. Alright, let's go straight into the lesson. Alright, so let us start with the stoichiometry definition. So what is stoichiometry? Stoichiometry is the determination of reactants required or products formed in a chemical reaction, right? So when dealing with the stoichiometry uses the principle of conservation of matter, which states that atoms cannot be created nor destroyed. This means that the amount of atoms on the reactant side of the chemical reaction equals the amount of atoms on the product side. For example, in this diagram we have, as you can see, the amount of reactants on the left side of the equal sign must balance with the amount of products on the right side of the equal sign. Alright? So in stoichiometry, we make sure that the amount of reactants and the amount of products, they balance. Right? So let's continue. So a chemical reaction is a change in which reactants are completely changed into new products. So a chemical equation is a short way of writing a chemical reaction using chemical formula of compounds and chemical symbols of atoms of elements. So in dealing with stoichiometry, chemical reactions are represented in form of balanced chemical equations. For example, if we have hydrogen gas reacting with nitrogen gas to form ammonia gas, we must ensure that the amount of hydrogen atoms on the left side of the equal sign equals the amount of hydrogen on the right side of the equal sign. This also applies to nitrogen. The amount of nitrogen on the left side of the equal sign must equal to the amount of nitrogen atoms on the right side of the equal sign. So in this case, the situation as it is, this is not attained. The amount of hydrogen atoms on the left side of the equation is not equal to the amount of hydrogen atoms on the right side of the equation. And this is why we need this equation to be balanced. Also, the amount of nitrogen atoms on the left side of the equation is not equal to the amount of hydrogen atoms on the right side of the equation. So here we have 2 atoms of hydrogen, while on the right side we have 3 atoms of hydrogen, not balanced. Also, we have 2 atoms of nitrogen and 1 atom of nitrogen on the right side, not balanced. So what should we do to balance the amount of nitrogen atoms on both sides of the equation? So since we have 2 atoms of nitrogen on the left side, we must also make sure that the amount of nitrogen atoms on the right side of the equation are 2. So how do we do this? By writing a 2 in front of this formula. So when we write a 2 in front of the formula like this, then it means that we have 2 atoms of nitrogen. However, when a number is written in front of the formula, that number affects every atom in that formula. So in this case, the number of atoms of hydrogen in this formula have been changed from 3 to 3 times 2, which is 6. So on the right side of the equal sign, we have 6 atoms of hydrogen, and on the left side we have 2. So to make also on the left side of the equation 6 atoms of hydrogen, we must put a 3 in front of hydrogen. So when we put a 3, it means now that hydrogen has 6 atoms, because when we multiply 2 by 3, we get 6. So in this case, we have hydrogen atoms 6, nitrogen atoms 2, and on the other side, nitrogen atoms 2, hydrogen atoms 6. So the number of atoms on the left side of the equation have equaled the amount of atoms on the right side of the equation. So let's get into the example. Example number 1 says, what volume of hydrogen gas is produced when 0.24 grams of magnesium reacts with excess dilute hydrochloric acid at RTP, room temperature and pressure? So in answering this question, so we'll say solution. First of all, we need to write the equation for the reaction. So the equation for the reaction is, we know that magnesium reacts, so we'll write magnesium reacts, so that term reacts with is represented by plus, so reacts with excess dilute hydrochloric acid. So hydrochloric acid is represented by the symbol HCl, and since it is dilute, it means it is in aqueous solution, right? Then they are saying produce, so the term produce is represented by the arrow, so produce. So in this case, what was produced was a hydrogen gas. So we'll put hydrogen gas here, H2, and here we are supposed to have G, sorry for putting S, because hydrogen is not solid, it is a gas. Then what we should know is that in this reaction, it is a displacement reaction in which magnesium reacts with the chlorine, and then what happens when magnesium reacts with chlorine? Magnesium chloride is formed. So apart from hydrogen, magnesium chloride is formed, and this is solid. So this is where I made a mistake. This was supposed to be here, and this was supposed to be here. All right? So this hydrogen, when magnesium picks chlorine, it forms magnesium chloride, and this hydrogen which remains forms hydrogen gas. All right? So let's continue. So from here, we are going to make sure that our equation is balanced by making sure that the number of atoms on the left side of the equation equals the amount of atoms on the right side of the equation. So here magnesium, we have 1, and also here we have 1. So with magnesium, there is no problem. So the number of atoms are balanced. Then we are going to move to the number of atoms of hydrogen atom. Hydrogen atom here is 1. Here hydrogen atom is 2. So to make the number of hydrogen atoms balance on either side of the equation, we must make sure that we add a 2 here, to make sure that here we have 2 atoms of hydrogen and here 2 atoms of hydrogen. So we will add a 2 here, so that now we have 2 atoms of hydrogen. However, this 2 does not only affect hydrogen, but it also affects the chlorine atom. So in this case, we also have 2 atoms of chlorine. Now, when we check on the right side of the equation, we also have 2 atoms of chlorine. So this balances the number of atoms of chlorine as well. Alright, so from here now, what we can conclude is that we have managed to balance the number of atoms on either side of the equation. So the next thing now to do is to make sure that we now know what we are doing. In this question, we are told what volume of hydrogen gas is produced. So for us to be able to calculate volume of hydrogen gas, we must know the formula that we must use. So the formula for calculating hydrogen is equal to V is equal to N times VRTP. So V is volume, N is number of moles of the same gas we are being asked, hydrogen. Then VRTP is volume at RTP, which is always given. In this case, it is 24 cubic decimeter at RTP, which stands for room temperature and pressure. All right, so as we continue answering our question, now we have to write what we call stoichiometric relationship or more-to-more relationship. So we are going to write a stoichiometric or more-to-more relationship for reactants and products. So these are reactants and these are products. So we are going to write a stoichiometric relationship. So this is how we write the stoichiometric relationship. So we'll say NMG, which stands for number of moles of magnesium divided by 1. This one here is a mole ratio of magnesium in the equation. So magnesium in the equation here is 1, and here we are going to put 1 here. Then we say equals, then we'll say number of moles of hydrochloric acid over 2, because since we have 2 here in front of hydrochloric acid, it means we have 2 moles of hydrochloric acid. Then equals number of moles of hydrogen gas over 1, because we have a 1 or we do not have a number here, which simply means we only have 1 mole of hydrogen gas, which also equal to number of moles of magnesium chloride over 1, because we only have 1 mole of magnesium chloride. Alright, so from here now, we are going to write a stoichiometric relationship between the substance given and the substance being asked. Alright, so this is what we are saying. We are going to write a stoichiometric or more-to-more relationship between the substance given and the substance being asked. So when we go back to our question, we are given 0.24 grams of magnesium, and then we are asked to find what volume of hydrogen gas. So we will write the more-to-more relationship between magnesium and the hydrogen gas. So in this case, in our equation, it is this part here, number of moles of magnesium and number of equals to number of moles of hydrogen gas. Alright, so this is a more-to-more relationship that we should consider. So our equation now becomes as follows. So our equation now becomes number of moles of magnesium over 1 is equal to number of moles of hydrogen over 1. Now what you should understand is that anything divided by 1, it's that thing. For example, number of magnesium divided by 1, it will be just number of moles of magnesium, which will be like that, equals also number of moles of hydrogen gas divided by 1. It will give us the same number of moles of hydrogen gas. However, you should know from the previous lesson on more concept, and if you haven't watched that lesson on more concept, consider clicking this video popping up here or this other video popping up here, because there I introduced the basics of more concept. So you must notice that here magnesium we are provided 0.24 grams. So however, we need the number of moles of magnesium to find the number of moles of hydrogen gas. So this number of moles of hydrogen gas are needed to substitute in the formula to be able to find the volume of hydrogen gas produced. So how do we find the number of moles of magnesium? Because we are given at least 0.24 grams of magnesium. So we can find the number of moles of magnesium by this formula. Number of moles of magnesium is given by M, which stands for mass, divided by 2 capital M, which stands for molar mass. So in this case, we are going to substitute, since the number of moles of magnesium is equal to M divided by capital 2M, meaning that where we have this value, we can also notice that number of moles of magnesium means small letter m, which is mass, divided by capital 2M, which is molar mass. That means that we can substitute where we have this value, we can put this value, so that our equation now becomes this value here is equal to this value. As we are writing it here, is equal to this. Now we are going to substitute. We know that M, which is mass of magnesium, is 0.24 grams, and we know that M, which is molar mass for magnesium, is equal to 24. So we'll say 0.24 divided by 24 equals number of moles of hydrogen. When we divide 0.24 by 24, we'll get 0.01 mole, which is equal to number of moles of hydrogen gas. So this means that the number of moles of hydrogen gas is also equal to 0.01 moles. Now we know the number of moles of hydrogen gas. Now we can go back to our formula, which says volume is equal to number of moles times volume at RTP. So now we know the number of moles, which is here. What is volume at RTP here? Volume at RTP is 24 cubic decimeter. It is a standard volume which 1 mole of a gas occupies at RTP. So we'll substitute so that here we have 0.01 mole, this value here, times here we have 24 cubic decimeter per mole. Then we are going to make sure that when this mole and this mole cancels, will remain with that. When we multiply 0.01 times 24, we'll get 0.24 cubic decimeter as our answer. If you are getting value in this video, consider giving it a like. It will go a long way. If you haven't yet subscribed, consider subscribing and turning on the notification so that YouTube notifies you when I upload the video on concentration or molarity and limiting and excess reagent. So let's go to the next example. So here we have example 2. Example 2 reads 0.25 moles of calcium carbonate are decomposed at STP to produce carbon 4 oxide. Calculate the volume of carbon 4 oxide produced. So let's look at our solution. So to begin our solution, we are told that 0.25 moles of calcium carbonate are decomposed. So calcium carbonate is written as CaCO3S. Since it is a solid and it is going to decompose. So to decompose meaning it is going to break into two substances because decomposition requires heat. Decomposition of calcium carbonate requires heat. This is why we have indicated heat above the arrow. So when calcium carbonate decomposes, it forms calcium oxide, which is it produces calcium oxide, which is CaOS as a solid, plus carbon 4 oxide, which is carbon dioxide gas. Alright, so from here now, what are we going to do? We are told calculate the volume of carbon 4 oxide produced. And we must know that the formula for calculating carbon 4 oxide is V is equal to N times VSTP. VSTP because this reaction happens at the STP. So the volume changes to STP. In our previous example, we looked at or we used the volume that was represented by RTP because that reaction was happening at RTP. Alright, so from here now we are going to now write the mole-to-mole relationship. Alright, as we understand the reaction happening at STP, that means that our volume here is always 22.4 cubic decimeter. Alright, so now that we understand here, our next thing is to write the mole-to-mole relationship between a substance given and a substance being asked. So a substance being given in this case is calcium, and the substance being asked is carbon 4 oxide, which is carbon dioxide. So number of moles of calcium carbonate over 1, because we have just one of it here in the equation, equals to number of moles of carbon dioxide over 1, because we have 1 here. So remember that before we do this, we have to balance the equation, and this equation was already balanced. 1 calcium atom, 1 calcium atom, 1 carbon atom, 1 carbon atom, 3 oxygen atoms, 3 oxygen atoms. This is 1 plus this becomes 2. So I didn't bother to show you that because I automatically knew that this one was balanced, but it is important that I let you know that it is balanced. So now that it is balanced, we write this mole-to-mole relationship between what is given and what is asked. Then if we divide this term here by 1, we get the same, equals, and this one also divided by 1 will get the same. Alright, so what now we are going to do here is to make sure that we substitute number of moles of calcium carbonate. We are told we have 0.25 moles of calcium carbonate. It means here we already have the number of moles of calcium carbonate. No need to calculate for them. So we have 0.25 moles equals to number of moles of carbon 4 oxide. So this means that number of moles of carbon 4 oxide is also equal to 0.25 moles. Alright, so now what now we are going to do is to substitute the number of moles of carbon 4 oxide, which is 0.25 moles, into this equation, and also this one get it into that equation. So when we substitute here, we put this, and on this one we put this. We'll make sure that we'll cancel the number of moles here, and then when we multiply 0.25 times 2.4, we'll get we'll get the volume is equal to 5.376. Alright, so guys, we have come to the end of this lesson. If you enjoyed it, give it a like. Until we see you in the next lesson, please bye and peace.